Hello and welcome to the next topic called as VLSM. VLSM stands for your variable length subnet mask. It is actually subnetting a subnet. Why we go for VLSM is basically in order to reduce the wastage of IP addresses, we go for VLSM instead of the FLSM. So let us get into the topic. So VLSM is called as your variable and subnet mask. It is subnetting a subnet. It reduces the wastage of IP addresses and it has flexible block size instead of the fixed size block. Say for example, if there are two departments, like one is requiring more number of hosts and if the other department is having only less number of hosts, in that case we can go for VLSM instead of allocating fixed block size for both the departments. So depending on the requirements we can allot, and whichever is having the highest number of hosts, that will be allocated first, then the least number of hosts will be allocated. So that is the concept that is used in your VLSM. So let us look at the diagram. So we are going to configure this VLSM requirements. So in this given diagram, we have two routers and two switches. These routers are connected in the serial interface, whereas the switch is connected via the gigabit interface. Likewise, the other switch also is connected via the gigabit interface. So in the next slide, we'll see what are the requirements and how we are going to proceed further. So this is the given question. So in the previous slide, we looked at the diagram, right? So they have given an IP address called 192.168.33.128/25, and they are asking us to perform VLSM. So BR1 is nothing but the router one. There is a requirement of connecting 40 hosts, whereas between router 1 to router 2, they need to connect 2 hosts. And for the router 2 LAN connection, they require 25 hosts, and the second router they need IoT connections 5 hosts, and CCTV they require 4 hosts, and also for connecting HVAC system they require 4 hosts. So this is the requirement that is given. So let us see how we can start solving VLSM. So how to perform VLSM? So the first step in VLSM, as we already mentioned, we have to arrange in the descending order. So the highest number of host requirements should be listed in the top. And then, for example, we have arranged it as 40, 25, 5, 4, 4, 2. So this is how we have to start doing the VLSM sum. So this is the first step. So this is the second step. So I have tried to solve using a pen, and that's how I have written here. So for example, let us look at the example. They have given the address 192.168.33.128/25. So we know by looking at the address, it is a class C address which has a network portion as 192, 168 and 33. So to solve any VLSM sum, the first step is basically you have to draw this table. So this table basically it is nothing but how many bits we are borrowing and what is the slash notation and what will be the block size. Okay, so if we are borrowing 1 bit, we'll get 128 as the block size and the slash notation will be 25. So if we borrow 2 bit, we'll get a block size of 68 and the slash notation of 26. If we are borrowing 3 bits, the slash notation will be 27 and the block size will be 32. So if we are borrowing 4 bit, the slash notation will be 28, the block size will be 16. So if you are borrowing 5 bit, the slash notation will be 29 and the block size will be 8. So like this, if you're borrowing 6 bits, the slash notation will be 30 and the block size will be 4. So in any class C address, we can maximum, we know there are 8 bits here, but we cannot borrow all the 8 bits. Why? Because first is the all zeros and all ones we cannot take. So we can have till slash 30 only. So that is the first condition you have to remember. So then I have written the requirements in the descending order. So first let us see, if I want to, first you have to find out for 40 hosts how many bits you need to borrow. So you have to check the table. So how many bits if you borrow, you will get 40 hosts. So if you're borrowing 3 bits, we'll get only 32. So that cannot be used. So we go to the next step. So if we borrow 2 bits, we'll get 64 addresses. So that only that we can do now. So the slash notation will be, new slash notation will be /26. So we have to write the address with the slash notation of 26, and then we have to add 64 here. So if you add 64, the new address will become 192.168.33.192. Now let us go to the next requirement. So for this 128 /26. So for that you have to write what is the first address, what is the last address, and what is the broadcast address, and what will be the subnet mask. So since we have borrowed 2 bits, the new mask will be 255.255.255.192. So the first valid IP will be 129. So when we add, we are getting 192, right? So the broadcast IP will be 191, and the last valid IP will be 190. Now let us go to the next block. So I need to get 25 host addresses. So here 16 is less. So obviously I have to borrow 3 bits. My new slash notation will be 27, and my block size will be 32. So the new block size will be 27. So you are writing /27, and we are adding 32 to 192. So which means now we'll get 192.168.33.224. Okay. So for this /27 means we are borrowing 3 bits, no? So the what will be the new mask? So it will be 255.255.224. This 224 is nothing but you have to add all these. 128 plus 64 plus 32 will give you 224. So 192 is the address, no? So the first address will be 193. So we have found out the next block is 224, which means 223 will be the broadcast, and the last valid IP will be 222. Yes, I think till this step you understood. Now we need to get 5 hosts. To get 5 hosts, if we borrow 6 bits, we'll get only 4 hosts. So this is violated. So we have to borrow 5 bits with the block size of 8. We'll get a slash notation of 29. So that's what we have written here. So /29, we have to add plus 8, which will give us to 232. So let us see in the next slide how to go about with the first and the last address. This is a continuation of the previous slide. So we have added till 232. So for this particular block, the mask will be 255.255.255.248. So the first valid IP will be 225. The last broadcast IP will be 231. The last valid IP will be 230. So next we have to get 4 host addresses. To get 4 host addresses, we need to, the next block that we are going to borrow is for getting the 4 host addresses. If you are borrowing 4 means 2 will be omitted. So we cannot borrow 4. If you borrow 4 means we will get only 2 valid IP addresses. So obviously we have to get 8. We have to get 8 as the block size. So which means we are adding 8. So the new slash notation will be 8 bits means what? It is the slash notation will be /29. So /29 plus 8. So this sums up to 240. So for this 232, the first valid IP will be here. It is 192.168.33.233. The last valid IP will be 239. The last broadcast IP is 239. Valid IP will be 238. So what will be the mask? The mask will be 255.255.255.248. So now again we need to get 4 more addresses. So that is the requirement. So again we will be adding plus 8. So now the slash notation will become 29. So the next is block size will become 248. So for this 240 range, so the first valid IP will be 241. The last IP will be 247. That is nothing but the broadcast. So the valid IP will be 246. The new mask will be 255.255.255.248. Now coming to the last requirement, we need to connect only 2 hosts. We require 2 host IP addresses only. So now we can take the block size as 4 with the /30. So now 248/30, we are adding plus 4. So which means the last block address is 192.168.33.252. So coming to this 248, the first valid IP will be 249, last valid IP will be 50, and the broadcast IP will be 51. Now what about the mask? The mask will be 255.255.255.252. So if we add all the block sizes, we'll get 252. So we have completed the calculation part of the VLSM in this slide. Now after calculating all the IP addresses, I have assigned, so I have taken the old diagram where I had two routers and two switches, right? So I have assigned IP address of 129 and 130 in this interface, that is nothing but the gigabit interface, and I have assigned 248 and 249 and 250 between the routers, that is nothing but the serial interface, and here I have assigned 193 and 194, that is for the other interface, which is nothing but the gigabit interface. And for the switch, I have assigned VLAN 1, and I have also configured the default gateway as this address, which is nothing but 129. So the same for this switch also, I have configured VLAN 1, and I have configured the default gateway as this interface. Now let us see the demo of this scenario using the Cisco Packet Tracer. I have configured all the addresses, and then I have shown how to ping from one switch to the other switch. I have also enabled the static route. Okay, so since we are using VLSM, we know different interfaces have different subnet mask, and also picking between these switches is not possible. So only if we enable some form of routing we'll be able to ping. So I have shown this scenario by enabling the static route for both the sides. Okay. So now let us get into the demonstration of the VLSM. So we have seen in the previous slide that we need to install VLSM network. So we have allocated two routers and two switches. Okay. So we are going to connect. So since the router and the switch are, we are going to use a straight through cable. I'm connecting via fast Ethernet. So switch, you can see there are 24 ports. I am connecting that to my gigabit interface. So between router to router, we need to connect a WAN interface. So here you can see there is no WAN interface. So what we have to do? So we have to install, or we have to add the external So click on the router, go to this NIM to T. So maximize it a bit. Okay, zoom in. So you can power off this module. Actually, if you power off the module here, we'll be seeing this attachment. So if you just attach this and power on, we can see the serial interface is coming up. Okay, so likewise, let us do for the other device also. Go to the router, go to NIM2T. In different things, you'll have different names. So zoom in. Here you can see the power button. So zoom out, power off, and attach the module and power on. Okay. So now here you are able to see the serial interfaces coming up. So first let us go and configure the addresses and mask. So the links are up. So I have attached a serial link. Okay, so this is my configuration, and we are going to do this configuration via VLSM and make the devices ping. Okay, so this is a simple scenario that we are going to do. So this side address I'm giving 192.168.33.130. So here I'm going to give 192.168.33.129. Okay. So here I'm going to give 192.168.33.249. So this side I am going to give 192.168.33.250. So here I am going to give 192.168.33.193, 192.168.33.194. Okay, so these are the various addresses that we are going to assign. So let us quickly go to the router interface and go and assign. Gigabit 0 bar 0, we have to assign 33.129, 0 bar 0, 192.168.33.129. Okay, so what about the mask? So for 129, we have to assign the mask as 192. We have done the solving, so you can refer that what we have done, and accordingly we have to assign. So next we have go to serial 0 bar 2 bar 0, and here we have to go and assign 192.168.33.249. So subnet mask for this 249 will be 252. So set it on. So as I already told you, since there is a clock symbol here, we have to set the clock rate to 64,000. Okay, so this router part is done. Now let us go to the next router part. So going to the router, so this is a serial interface. So serial interface, we have to go and assign the address 192.168.33.250. Okay, what about the mask? So for 250, the mask will be 252. Okay, power it on. Next, we have to go and configure the gigabit 0 bar 0 bar 0. So in gigabit 0 bar 0, the address that we are going to assign is 192.168.33.193. Okay, so what about the mask? So 193 means we have to assign the mask as 224. So we have to assign the correct VLSM mask. Otherwise, the address will not be valid. Okay, just power it on. Okay, so far we have done configuring here and configuring here. So now we have to go to the switch part. So switch is a layer 2 device, router is a layer 3 device. So for example, if I want to pick from the switch to the router, actually the switch is not having any IP address by now. So even if you ping, it will be a failure. So likewise, even if you ping from here to here, actually the link is down. So if I ping to router, it will be a success. But if I ping from a router to the switch, it will be failure because we have not assigned any IP addresses to the switch. Okay, so we cannot assign any IP address to the switch. Instead, if you click on the switch, since I already told you, so there are 24 interfaces along with gigabit. So we cannot go and assign IP address to the to this fast Ethernet ports. So only thing is what we can do is we can go and assign the VLAN 1 IP address. VLAN 1 is nothing but the management VLAN. So first what you have to do, you have to type the command called connect T And then we have to go to the interface VLAN 1. So VLAN 1 is called as your virtual LAN and it is the management VLAN. Okay. So there we have to go and assign an IP address. IP address. So what address? 192.168.33.130. The mask 255.255.255.192. Okay. After assigning, we have to give the command called no shut and then exit. Okay. After that, we have to go and configure the default gateway. So just give IP default gateway. So the default gateway will be the router's interface. So the router's interface will be 192.168.33.129. Just come out. Okay. So for this switch, the default gateway should be this address. So that's what I have given. So likewise, I have to go to this switch and I have to give default gateway as this address. So let us go into the other switch. Go to the CLI. So enable connectivity. Here also I have to go and say interface VLAN 1 and then I have to go and give the IP address. IP address 192.168.33.194 with the mask 255.255.255.224. Okay, so that is the mask there. So then go and give the command called no shut. Come outside and go and give the command called IP default gateway. So the default gateway was 192.168.33.193. Okay. So we have given the address so the other side also. Now let us try pinging. So we should be able to ping from here to here. Okay, always I told you first time it will be a failure. So likewise, the other side also it will be a failure first time. So now you got a successful message. So we'll be able to ping from here to here. We'll be able to ping from here to here. From here to here, you will be able to ping. But we will not be able to ping from this switch to the other switch because we have used routers in between. So we have to enable some form of routing or we have to configure the static route. So in order to, from this switch, in order to reach this particular network, okay, so we have to go and give the next stop. So for this router, the next stop will be 249. So likewise for this router to reach this network, the next stop will be 250, 33.250. Okay, so let us say this 2930. So for this 12930 will be basically coming under 128 network. Okay, so we have to go to this address and say static route. Okay, so I want to reach to 192.168.33.128 network with the mask as 26. So 255.255.255.26 means 2 bits. So it should be 192. So the next stop will be the router address. So the router address is 192.168.33.249. Okay, so I want to reach the other network. So this is the next stop. So add. Okay, we have added for the this
router. So now let us go to the next router. So this 93 and 94 comes under 192 network with a slash 27. So go to static. So 192.168.33.192. The mask is 255.255.255.224. Okay, so the next hop for that is 192.168.33.250. So this is the next hop for this network. So once you are done, now almost our configuration is done. So now we should be able to ping from one side to the other side. So we got a successful message. So here also we got a successful message. So now this is how we have to test your VLSM network. So we have assigned two addresses here with the slash 30. So this is 192 network with the slash 27. So this is 128 network with the slash 26. So let me write it here. So this is a slash 26 network. So this is a slash 30 because we have got only two addresses. So this is a slash 192, right? So it is slash 27. So we have used slash 26, slash 27 and slash 30. So we have configured VLSM and then we were able to test the data transfer from one end to the other end. So I hope you understood the concept of VLSM with the real-time implementation. So you can also go and check for the details. Okay, you can also go and ping in the command prompt also. Okay, in the switch also you can go and ping. Okay, so that's it, students. So you just do it by yourself, understand the concept and try it by yourself. Thank you.